In this lesson, we're going to be talking about something that's critically important for all of chemistry, and that is measurement and units. This is one of the really important things. When back in 1999, NASA launched a Mars probe, and that probe ended up hurtling straight into the planet and got crushed into a million pieces. And what had happened was that the NASA scientists were split up into two teams, and one team was using the imperial units and one team was using metric units. And that ultimately resulted in a failed probe launch. And so this kind of points to a really big issue, and that is making sure that when we measure things, that those measurements are going to be the same regardless of where we are. Way back in the day, scientists had this problem constantly. So one scientist would measure the length of something and they would say it was length of, say, 8. But that didn't really indicate whether it was 8 kilometers or 8 inches or 8 micrometers. If they communicated that length was 8 to another scientist, that other scientist may not get those measurements and dimensions right. And this is true of just about anything we can measure, such as like temperature. Okay, if you go outside and say it's 0 outside, if you're talking about degrees Fahrenheit, then that's really frigid. If you're talking about Celsius, that's still pretty cold, but it's not quite as cold. That's about 32 degrees Fahrenheit. And so there's some really big differences in the way that we measure things and the systems that we use. And this caused a big problem for scientists for a long time, and still continues to be a problem for scientists from time to time as well. So to get around this, in chemistry and in most of science, we use what's called the International System of Units, which is the SI units. Around the world, they defined 7 different be the basic default staples of measurement. Okay? And these measurements are completely independent of each other. That means that, for example, if we look at the first measurement, length, which the SI unit for length is meters, so whenever we measure length, it should always be in meters, that length is in no way influenced by the mass of something, and the mass of something is completely independent of its length. Okay, so that these two things don't depend on each other. And so the mass, the SI unit of mass, is kilograms with the abbreviation kg. Temperature we measure in Kelvin, which we'll get a lot more into in the first unit. Time is measured in seconds. Notice we're not measuring anything in minutes here. Okay. The amount of a substance is measured in moles, and we'll get into that one a little bit later as well. But really, a mole is just a way of counting things, similar to the way the word dozen or pair counts things. Electric current is another one, measured in amperes, and we won't really do that one much in this class, as well as luminous intensity, which is candelas, which, again, we won't really look at too heavily in chemistry. Okay. Now, all of these measurements are completely independent, but because these measurements are independent of each other, one does not depend on the other. We use them to actually make compound units. So here's a good example of that in action. So the formula for the speed of an object, or the velocity of an object, is distance divided by time. How much distance does it travel divided by how much time it takes to travel that distance. Now you'll notice both distance, or length, and time are SI units. The measurement for length is in meters. So let's say, for example, an object travels 5 meters is its distance, or the length of distance that it travels. And the time is measured in seconds, so let's say it takes 2 seconds to do that. Plugging that into our equation, we would say that the speed is 5 meters over 2 seconds. And so we would say it's traveling at an average speed or velocity of 2.5 meters per second. So this is a compound unit. It was we got this by dividing the length of something divided by the time it took to travel that length. Okay, so this is a compound unit. Now, sometimes compound units get really complex, and so we abbreviate those into other units. So, for example, pressure in the SI system is kilogram meters per second squared. So we multiplied the mass of something times the length of something divided by the time squared. Okay, and that's really where that comes from. But because that's inconvenient to write all the time, a lot of times you'll see pressure written as pascals, or there's a lot of other units there as well. Okay, but kilogram meters per second squared is the SI system. This is the default system. Now, it's one of the important things about this system is measurement. So the system isn't really helpful unless we can measure these things. Okay, pressure and other compound units have their own tools and devices that we can use to measure them. Like you can use a pressure gauge to measure the pressure inside the tank of, say, like a propane tank on a grill. But in terms of some of the more basic and fundamental things we'll be using in this class, like if we look at distance and time, we measure time with a stopwatch, anything that you can measure seconds with, and distance by a ruler or a meter stick or something like that. One of the really important ones that we're going to be measuring very frequently as well is volume. And volume can be a little bit tricky to measure because there are three big things that we'll be using pretty often in this class, three types of glassware. There are graduated cylinders, beakers, and Erlenmeyer flasks. Now notice these are all shaped differently, and that's because these three types of glassware all have different functions. A beaker is pretty much like a standard cup. This is where we do a lot of the basic things. It's just a container for holding things. Erlenmeyer flasks are really, really good for swirling. Okay, so for example, if you got vapors coming off of something or you want to swirl it so that it doesn't splash out, Erlenmeyer flasks are really good for that. And you'll notice that both beakers and Erlenmeyer flasks are graduated. And what that means is they have lines showing volume. Okay, and beakers have those as well, although it doesn't really show it so well in this picture. But the thing is, when it comes to actually measuring volume, you should always use only graduated cylinders. And here's why. Graduated cylinders are narrow, okay, and they have a very small diameter. And what that means is that you can take much more precise measurements, because if you add a few drops of water to a graduated cylinder, you'll probably actually be able to see the water level rise inside this container. But if you add a few drops to a beaker or an Erlenmeyer flask, you won't really see any change in that water level, which means that these beakers and flasks are not really good for measurement. So a really big pet peeve of mine, and a lot of times college professors get really big on this too, is seeing students measure volume using a beaker or Erlenmeyer flask. You should always avoid doing that and always measure the volume of a liquid using a graduated cylinder. And when using a graduated cylinder, it's always important to measure the volume at the meniscus. Okay? Because water molecules are very adhesive to polar substances, which we'll get into what all that means later, the water molecules cling to the inside surface of a graduated cylinder. Okay, so it kind of wants to climb up the surface of that a little bit. And so what it does is it forms sort of a bowl or a pit, okay, where the outer edges here are climbing up the walls. And the bottom of this pit or bowl is what we call the meniscus. And the meniscus is what you should always use to take that volume measurement, because the amount of water climbing up the edges is more or less negligible. Okay, we don't really count that stuff. So even though if you look at the edge of the water on this one, it looks like it's going up to 7, this measurement we would really take at about 6.8 or maybe even 6.7, depending on how you read that. Okay, and so it's also important in order to see the meniscus that you should always hold a graduated cylinder at eye level. Okay, so you should always be at eye level looking at that meniscus when you take that measurement.